All right, so hopefully you guys got the program up. Um, I did send a library so you guys can follow along. You can make your own libraries. I can show that a little later in the video how to do it. It does involve a little bit of time, and depending how complex the part is, can take quite a bit of time. So if you need to set up your like the library where your parts are, I think it's in the your documents Eagle, and then we'll have like library, and you can just put the file in there, which will be in this managed libraries right here. So it already comes pre-built with like a shit ton of stuff. You know, each one of these libraries has like lots and lots of parts. But there's always some specific ones or newer ones you need to make something and it's not there. So this is where you would use the website that I linked, which was I think it was Snap EDA. Let me see if I could find it. Yeah, right, yeah. So this website, which I'm going to have to move over. So this website here is where you would go and find whatever it is you need. You probably got to make an account. It's free, so it's not a big deal. Okay, so you would put the part name, and there's usually like a bunch of them. There's it's all based on different packages. For this particular chip, there's only the TSOP. So, and then you look at the data available. So the first one's a data sheet, the symbol, the footprint, which is very important, and a 3D model. So if you do an export of the PCB into Fusion 360, it'll actually show the chip. Avoid any of the ones that don't have what you need. Sometimes you find parts here and it only has the data sheet and nothing else. So that kind of sucks. You have to make your stuff, but so this is the symbol that's going to show up when we do our schematic. It's a little different than what's on the picture here, but it's all good because everything's labeled. We just got to match the labels. Then you would just do download and symbol and footprint, and then you would choose Eagle and save it to whatever folder you want. Okay, well, we can get rid of this now. So I'm going to show you guys also, I put a few folders, the CAM, the DRU, and the ULP. So all of these folders would normally be in your C drive where it installs. So here's Eagle, and you just copy these folders over here and overwrite whatever's here. It's just going to add the custom ones that I made. So these custom ones is usually for production. So once you have your circuit board and everything designed the way you want, you would use those files there so that we can actually create a circuit board. So I'm going to assume everybody's on up to this level right here. And so you would go to projects. You'll see I have tons and tons of projects. So what you do is you right click and create new project. We're just going to call this THS 7374 RGB amp. Okay, so the little green circle you'll see, this is this indicates that this is your active project that you have open. You right click and we're going to do new schematic. Oh, almost forgot. When you put a new library, which I didn't do, you have to enable it for whatever reason. So on mine, I have it as an Eagle Custom Parts. Let's put newer libraries. And this is where I would put it. But since I forgot to copy it, let's go back. Okay, I'm gonna copy this. Okay, so the library is there now. So now I would go where the libraries are. For me, I have it in custom parts, but you can put this wherever. And you're gonna have to enable it. So right here, here's the part we just put in there, the library, but it's not green, so we have to click on that to enable it. Otherwise, it won't be able to show up when we're in the schematic. So I'm gonna go back to the schematic page. We're gonna click on this button to add the part. So you can scroll down, or you can type it in. Sometimes it works with custom stuff, sometimes it doesn't. Okay, this one did. So this is going to show you the icon, and this is the footprint of the chip. So either click OK or just double click on it. Once that's done, you hit escape, and that brings us back to the part library part. So now we're going to need a few other things. If you look at the schematic here, so we're going to need, this is VCC. Also going to need, this is ground. They have it pointed up. Normally 5 volt VCC points up and ground points down in most schematics. So we're going to need a ground, and we're going to need the VCC or 5 volts. And we're going to need some resistors and capacitors. We're going to do each one at a time. So right now we're going to do the power rails. So we're going to just write VCC. It's usually down here. You have two options. You got the arrow and you got this circle. I like this one. It's just my preference. You can use whatever one you want. We're just going to put it up here. Hit escape again. We're going to do ground, so GND. And you have two options again, the line, and you got this down arrow. I like the line, but again, this is my preference. You can do whichever one you like. Okay, so next we're going to need resistors. I'm going to do through hole components, and then we're going to go back and switch it to surface mount. I just want to show you guys how you can switch parts on the schematic, and it's going to affect the circuit board, you know. And also for anybody who wants to do simple boards and you just want to do through hole components, it's actually resistor, no S. It's going to bring up tons of libraries, probably not the same as the ones I have. So the only thing we need to go to is right here, the RCL. You got the USA symbol, which is this one here, and you got the European symbol, which is the square. I like the USA one. Again, it's preference. It doesn't mean jack shit when you're getting the parts made or ordering or anything like that. It's just a symbol on the schematic. Now this is important. So if you click here, you're going to see like 2 vias and like the yellow circle. The yellow circle would indicate this is the part. So this is basically like the resistor is standing up and it goes into hole, and then the other leg would go into this one here. So if you want, this will give you kind of a high PCB because the parts are standing up instead of laying flat. So I'm not a big fan of that. But again, this is totally you. This is more the typical idea of what the resistor would be like. Where you have one lead going here, here's the body of the resistor, and then it goes into the other via. But there's different sizes, you know. So I'm not sure what size resistors you're planning on using. So we'll stick with this medium-sized one here. I'm just going to lay one because we can copy as many resistors as we need. Now we're going to do capacitor. Capacitor, again, there's a bunch of shit. and there's also the RCL, which is typically what I use. So one of these RCLs, you're probably just going to have one. One is edited. I edit it so that the footprint is a little better for a little more accurate to the data sheets for the parts for a surface mount. But we're not doing surface mount right now, so it really doesn't matter. So if we look at the schematic, these look like they're all uh, ceramic. So there's no polarity. If I zoom in, there's no plus or minus. So that tells me it's a ceramic cap, no polarity. So what we're going to do is we're just going to, again, this is up to you, the preference. So this is the European symbol, and here is the USA symbol. I really don't like the USA one. This bugs me. I like it when it has polarity. So if there's like a positive and a negative, I like this one as opposed to this one. Again, personal preference. But since we're doing through hole, I'm just going to go with the European one. So this right here would be perfect for what I'm looking at for the values, which is those little disc capacitors, the ceramic disc capacitors. Yeah, these are all 0.1 UF or 100 NF. Same thing, just different ways of saying what the value is. Okay, so we're just gonna, I'm gonna put 1, but it looks like we need 1, 2, 3, 4, 5. Okay, so we're gonna do 5 of those. Let's see. This is a good medium size. We'll go with this one. We know there's like 2 on the output and a bunch here. All right. And another thing, if you look here and also here, you have these outputs. These are like test pads. So what we're going to do is we're going to start laying out our test pads and where to get those. So again, you can search. If you cleared the search bar and just hit enter, it's going to show you all the libraries. But since I've done this quite a bit and I know the libraries I need, you just write tests. Okay, so this one that says test pad old, I typically use this one because it has a bunch of things that I edited. For example, it has this rectangle one. So if these are circle and square test pads, but I wanted to have a rectangular one, so I made one for my own personal uses. But since this is through hole, we can stick to through hole. So at the top we have the through hole parts. So you got these kind of pads. The bigger the number, the larger the size. So 20 would probably be kind of large. We'll stick maybe with what's 17. So 17Y, which is this longer one. If you wanted to go with this one here, you can do that as well. So we just double click it, and we need to face. If you right click when you have a part highlighted, you can rotate it. So right clicking on the mouse rotates the parts. So I'm going to keep them rotated that way because the traces will go from where the thin part is. So it's going to come this way. This makes it easier for routing. You can space it out as much as you want. I think there's 4. Another 4 on this side. Again, we can always add more. Okay, so looking at the schematic here, we have 4 and 4, yep. And how many resistors do I need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So 13 resistors. So all we got over here, these buttons, we have the copy and paste. So if you click on copy, you'll see a little gray square. It's highlighted. That means it's been chosen. So you just click on the resistor, and it'll copy that or whatever you click on. So since it's still highlighted, I can click on it again, and you click as many times as you need until we got the number we want. It's going to look like a mess, but we're going to organize all this. Control Z because I made a little mistake. You never want to put the resistors like butting up to each other, because then it'll make a connection. When you push parts up to each other, it'll make a connection. Then you would have to break it later. So just leave a little space. Okay, we got our 13. Okay, we have a few more test pads down here that I did not see. So this is the voltage in and out and the ground. So we'll put 2 more pads since we already have them out and the copy is still highlighted. We just click on that. Okay. All right, so now we can start naming these things. So if you come over here, you have the name. You can also change the name of the resistors, to be whatever you want. But if you can't use the same number or the same name multiple times. You're going to have to either hyphenate it or put a number in before or after it. Okay, so this one, looking at the schematic, J1, J2. I'm not going to name it those. I'm just going to make it simple for us. So since this is RGB, I'll just put R in for red in, G in for the green, B in for the blue, and this one would be sync. So I'll just put S in. And over here, we're going to do the same thing. So we're going to have R out, G out, B out, and S out. And since we're at it, let's do this as VCC or 5 volt or whatever you want to name it. Something you know what it is. I'm going to label it VCC, which is pretty universal for the voltage and ground. Alright, so I'm going to put this on the bottom here. And we're going to put the VCC, you butt it up to the thin part of this symbol, and you can click it again and you'll see the green line. That means there's a connection there. Those two are connected. Ground, generally you want to face down. It's just the way it's done more proper, but you can face it up, whatever, it doesn't matter. This is your schematic, unless you plan to share it and you want to get scrutinized by the engineers out there that will complain, oh, why is ground not facing down? It's whatever, in all honesty. But if you want to do it the proper way, I'm going to try to show it so you guys can pick up good habits instead of bad habits. I'm just going to spread these out a little bit, just so we can see the name a little easier. Okay, so we're going to start adding things. So we got 1K resistors. I'm just moving things out of the way so we can emulate the schematic. You want to try to stay in order, but you don't have to, because the output, it's all going to go to a machine. The machine is going to place the parts, unless you're going to do it manually. Then it might be easier to keep things in order for you. Okay, so these are 1K. So if you come over here, you have the name, so you can actually change this to whatever, and also the value. This is where you want to start putting things. To make it quick and easy for me, I'm just going to copy, so I can copy paste. And now we have 1K. Alright, and then those connect to these capacitors. So this one here, the first one, has nothing. So I'm assuming this might be the sink. It doesn't have a capacitor to filter. So I guess we can skip the one on the bottom there. So this is 0.1 UF microfarads. We're just going to put the value in all of them. Okay. You zoom out a little bit so I can move these out of the way. So as you can see here, what they've done is they've pushed it forward and then angled it down just to get in line with this. We could do that as well. You don't need to follow this exactly as it is, as long as the lines are connected, the traces. Alright, since we said this one is likely sync, we're not going to put a capacitor as it shows over here. Alright, so this green symbol here is the traces where we do our nets. So you would just click on, you'll see the circle as soon as you move the mouse over. That's where you can make a connecting point. You can also, I'm going to go to the move tool. You can also do what I said earlier. If you just butt them up and you can just pull it back, you'll see it made a connection. So there are various ways to do this. Because the legs of each connection is pretty close together, we can use this right here, the group tool, and you just highlight this entire area. Click and hold, and you can move whatever it is that was highlighted. We're going to try to bring it a little closer so we don't have like a bunch of traces going all over the place. I don't think it sucks if you get too close, then things kind of overlap it. So it's not a big deal, but so you guys can see what I'm doing, I'm going to leave a little bit more space. So we go back to the net, click here. You got to be careful. You see how when I did that, it went down on the right side here. If you do that, it's going to connect these 2 points. You don't want that. So if that happens, you just right click on the mouse and it'll change where the drop down will come. You can also just go straight, click, and then you can, once you click, you're already making like another point where the trace is going to go from. Okay. So we're going to continue copying. So these resistors are pull down resistors because as we see here, this is ground, this symbol. So we're going to add a resistor. The resistor comes after this resistor, which looks like, to me, it looks like a voltage divider. When you have something coming in, there's a resistor here, and there's another one that breaks off, usually into ground. It's a voltage divider. But we're just following the schematic, so we're not here to figure out the circuit right now. This is mainly if you find something and you want to make it, or you have a simple schematic where you can make it into a circuit board. Alright, so I'm going to grab the resistors. So we're going to do just like it shows in the schematic there. We're going to put 2 on top, 2 on the bottom, just so it doesn't get all clustered up. Again, I'm using the right. Once I click on something, and it's green, it's highlighted. If you press the right mouse button, you can rotate. All right. And I'm going to go to the copy tool. I'm going to copy the ground, which is the symbol, not the test pad. We want the symbol. And I'm going to put it here, and I'm going to copy it again and put it here. So in case you don't know, ground is pretty much shared amongst all ground. Same thing with 5 volt. Wherever you put this symbol, it's all connected. So if you just have one ground and you have two parts that are all connected to ground, we could just butt them up together like this. You can make a connection and then connect that. It's going to say, are you sure you want to put this net segment into the ground? Yes. And then we can do to this, and this will go to this one, which if you look at the schematic, we got one that connects to this bottom trace, and then you got this one that connects to the next one. And we're going to do the same thing at this one up at the top here. It's going to give you the message, are you sure? Yes, we're sure. So this little green dot indicates that there's a connection. Connection there, because if otherwise you look at this, you see this trace goes over this one. If you don't see the green dot, then you know this is not connected to that. So that makes it easier to look at a schematic and figure out what's going on. Some of the older schematics I've seen out there where it's just a bunch of traces overlapping, you have no idea what's connected to what. You know, it's a mess. So you see the green dot, you know it's connected. You can also place the dot right here, a junction. So if for whatever reason the program made a mistake or forgot to add a junction, or you manually want to add a junction, you can do that. You click that, and then that will tell the program that this is connected to this trace as well as that trace. Okay, let's see what else we need to do. When you have something chosen here on the left and you don't want it anymore, you can just hit escape and it'll go back to the group icon. That's like the default one. It always goes to that one. Let's look at the schematic here. Okay, so we got this whole area taken care of. So now we'll take care of this part right here, the ground and the VCC, the 5 volts. So once again, we're going to copy the ground. So NC is not connected, which has an X. You can totally ignore that. So remember what I said, oh, sometimes it goes down like that. This time we want that to happen because these two pins will be connected, and you'll see it, the program automatically made the junction point. So that tells us this pin is connected to this one, which is then connected to ground. If you on the mouse, the wheel has a button, so if you press and hold it in, you can move the entire schematic around. So you'll see me do that if you know, and you might be wondering how the hell do you do that? It's the mouse wheel button. Okay, so let's look at this again. It goes to 5 volts, and these two capacitors connect to that. And what's it say for the bypass? Bypass, we have something else to do. Alright, so we're going to copy the VCC again. I'll just put it over here. We'll move it around as we need it. And the ground to these two. So what I'm doing here, I'm moving the part instead of like moving it and making a trace. And I as long as it touches one of either end of the of the part, it's going to make a connection, and you'll see the junction. It says you want to put this trace into VCC, we're going to say yes. We can push it over. So if you move it around, you'll see that it's connected. Same thing can be done here. So we can do that and touch that, and there we go. So that's another way of making their connections. Okay, so we need to... Oh, I forgot about this jumper. But we can find that. Not a problem. So this is for the low pass filter to turn it on or off. So since we didn't have that jumper, we're going to add that now. If you write jump, all right, let's try jumper. I know there's a jumper in here. There's a bunch actually. This one you might not have, but these here you very likely will. I think this is one of the custom parts that I made. And again, we want to do through hole right now. So here's a perfect example. And it actually matches that symbol. Alright, let me see. Oh, they got it facing down, so we could do that too. Alright, so we'll grab one of the resistors. We're just going to keep going in order, so we're not jumping around. It looks like one of them goes to ground. Yeah. So since ground is right here, we can just run a trace. Let's have a look again, just to make sure. Okay. This is 10K, so we're going to add the value. I'm going to move it. And we can copy. If you don't want to copy, you can just run a trace. It's not a big deal. So run a trace from the 5 volt here. Because 5 volt's going to be, again, see, I'm trying to like get it to switch over. If it's not working, just right click and it'll change the way the trace routes. See, I almost made a mistake there. I was going to go straight up, and then once I do that, it's going to butt up to this, which you're going to be grounding it. You don't want that. You don't want to touch traces to traces, otherwise they're going to make the junction point. Let's make sure that's correct. Okay, and then this connects to number 2 here. So basically this is a pull-up resistor that keeps this high. When you close the jumper, it grounds it, which will put this to ground. Without the resistor here, that would cause a short, and it would could damage the chip, very likely, just cause it to reset momentarily. But if you're putting VCC to ground, you're going to cause damage not only to your console, to the board as well, the chip. Okay, so let's get the other resistors in line. You can just butt them up, and then you can push them out a little bit, just to see that there's a connection there. As far as I can see, these are all 75 ohms. 1, 2, 3, 4. Oh. So resistor 1, which we determined is likely the sink, is 200 ohms. So we're going to make sure our 4th one, because we swapped it here where the sink is 200 ohms. So we go back to value. Click on each part. You can move these around after, like if you want to see better what the value of each one is, but we know what it is. That's all that really matters. So over here, let's look at the schematic once again. It goes straight to the pad, so we can just do that. Okay, so if certain things are kind of bugging you, just the way you're looking at it, you can click on wherever you see that plus is where you can grab things. So if you click on this, you can move the words around. So you can actually rotate it and put it this way. I know some people can get OCD. Like this VCC, I can just move it off to the side. Okay. Now that's a little better. So the schematic pretty much is done from what I could see. So now once we got that done, if you want to move things around, maybe you want to bring it closer, you can do all that. But schematic is wired. There's nothing else we really need to do unless you want to make it look a little prettier. Bring things a little closer. So if you click on this icon here, this is the zoom features. If you click on this, it'll just zoom to fit. So now everything's on screen. If you want to share your schematic, you can easily take a screenshot of this, and it's very legible because we moved everything closer together, so the image is bigger. So once we're done, well, let me show you a few other things so you guys know what some of these buttons do. So if you want to add text to help you determine something, like for example, I'm going to put here, I'm just going to write pull up or low pass filter on, as it shows in the schematic, and you just got to choose what it's going to be. It doesn't really matter, it's not going to affect anything, it's just the colors. If you want to make it look a specific color, like, you know, purple, to make it stand out. You can also change the size. I'm using the wheel. Vector is the one you really want to use because especially on the silk screen, the vector, whatever it looks like in vector is what it's going to come out when the circuit board's made. If it's one of the other options, fixed or proportional, it might not look exactly as you have it on your board design. And then the ratio is how thick you want it to be. The more ratio, the thicker it is, as you can see. So I'm going to put that over here, and we know that this is the low pass filter on. If you have any other jumpers or anything else you want to point out, you know, the text is good for that. A lot of these symbols here you're not going to really use until you get to the board view, which is what we're going to do next. This one is very handy, mirror. So for instance, sometimes you have a socket that has a bunch of pins and you want to rotate them so that, like, say 1, 2, 3 up to 7 is on the opposite side. So if I click on this, I'm going to do the move tool, and if I rotate it, you'll see it'll be on the other side, but the numbers are start from the bottom up. Again, this is just for making it easier for you to route things, because whatever's routed in the schematic is going to be a little different from, like, you can't physically change the pins, but you can in the schematic, which makes the routing easier for you. So if you click on mirror, it'll flip this over to this side and it'll be in the same orientation. I'm going to do that. You're going to see a bunch of these junction points because it's going to also flip, you know, what the traces are. As you can see, it's jumping from across from one side to the other. But now you'll see 1, 2, 3 up to 7 is on this side in the orientation we wanted. So Control Z, and now I'll bring it back to the way it was. Okay, so once we got this all done, now we're going to start working on the board. So we come over here to generate, or switch to the board. You click on that. It says there is no board made. Would you like it to create it from the schematic? We're going to say yes. Okay. And this is where we're going to put all our stuff. Okay, as you can see, these pads are pretty large. So we can go back, click on the schematic button. It changes for the schematic when you're in the board view, and when you're in the schematic view, it goes to the board. So since these are pretty large, we're going to replace it. So I believe it's this one, yeah. This icon here will replace whatever it is you click on. So we're going to go back to test. I think we used the 17. This was 17 here. I believe that's what we used. So let's go with the 13. So double click on that. And basically you're going to click on the part you want it to replace, where it has the little red crosshairs, the little X, if you want to call it that. So you click on that. Nothing showed. You'll see like a quick flash maybe. I'm not sure if it's catching it on video, but just make sure you click it on each one, and then we'll go back to the board view, and we're going to see. I'll leave the ground alone just so we can compare. So if you come here, yeah, they all have come down in size except for the ground. So we can go back and do the same thing and fix the ground. So okay. So since we have the schematic here, it kind of gives you an idea how it's laid out. We can try to emulate this in board form as well. So we have the inputs here and the circuit board. We're going to move the circuit board, not the circuit board, the chip somewhere here. We're going to, this yellow line is the border of the board. So you can move it in, you can do custom shapes, custom sizes. I'm just going to bring it down a little bit, something manageable, and then we'll readjust as we need. Okay, so we have RN at the top. If you click on something, one thing about these test pads, you'll see if I zoom in real close, it has the name. Like if I click on here, if the green pad isn't highlighted, it's because I highlighted this text. So when you click on something, if multiple items are overlapping, if you click on one of them, you'll get this move arrow as I have here. But if you right click after you do that, you can switch between the parts. So if I right click, now I'm going to be able to move the green pad, which will then move the text as the text is connected to this test pad. So I was going to move it off to the side. So whenever you use test pads, this is going to happen. This little text is going to be there. You can just click on it and delete it, or come over here to the trash can, delete it. That's not going to be needed or necessary. But it's something you're likely going to click and you'll be like, oh, I clicked on that. How come it's not moving? It's because that little text is in the center. That's part of the library. To fix it, it's quite a bit of work. So I just totally ignore it. So whenever I click on it, and if it doesn't highlight right away, like this one, I just right click and then I know it's going to choose the pad. So we're going to do R. Again, if this is too big, you can always go back and change it. There's that damn icon again, the little text. See if I can delete it. Okay, and we're going to need this one. So another thing you want to do when you come into the board, you'll see here it's 50 mil, which if you go to the grid, I like to put the display on just so I know where the parts are going to snap to. So this is 50 mil. Generally, most people, pretty much everybody, uses millimeter. So in millimeter, this is 1.27 millimeter, which two of these is 2.54, which is the typical spacing of like headers and most through-hole parts. So we'll leave it at that. We can all alter it later. And this alt, this is good when you want to have like more precise control. So put this in millimeters. As you can see, it's like 10 times the difference. So the alt, in order to use it, is when you have something highlighted. I'll just use this for example. See, when I go to this one space to the right, it snaps to that grid line. But if I hold the alt button on your, I think it's alt. Let me see. Yeah, alt on your keyboard. When you have something highlighted, now you have much more precision. You're going to be moving the part at that 10 times smaller value. So as you can see, it's much smoother because I can actually move it wherever I want according to that number we put. Once you let go, then it snaps into the grid again. So sometimes if you need something to like precision, you can always just put something really low here. So a lot of times I put this as like 1 or 01 because I actually put this much lower. But again, for this tutorial, stick to more default options until you get more familiar with the program. All right, so next is one of the resistors, and if this is why it's good to pay attention and have everything numbered. Makes it easy for us to know that resistor 1 is going to be coming over here. And then 2, 3, and where's the fourth one? Okay, we can move this a little closer. But we also got to remember, according to the schematic, we have another resistor on each line. Then we have the capacitors. So we're probably going to have to move this out more. And don't be afraid to increase the size of the boards. If you're going to get this like a PCB Way or JLC PCB, they're all relatively cheap, But if you want to make the board smaller, you're going to have to really squeeze parts in there. Like all these are kind of close together, so I'm going to choose the group and just highlight them all. Click and hold, and that will move everything up. This way it gives us a little bit more room to put some stuff down here. How you lay out your board is up to you. All right, so again, the right mouse rotates the parts. All right, we can actually move this like over here, because we're gonna run the traces, and the way we run it, we can, because it's through hole parts, you have a lot of space on top and bottom where you can route things. Okay, let's do the other ones. Obviously, you don't want to do this. You see the part is kind of overlapping, the V is overlapping the part. So you don't want to do that. So we can move everything up, or we can just lay it out this way if we want as well. There's no right or wrong way how you lay your parts out. got the capacitors. Oh, this one, as you can see if you zoom in, VCC and ground, so I know for a fact that's these two here. Okay, here's the jumper. I'll put the jumper somewhere over here, kind of off to the corner. Again, like I said, there's no right or wrong. You can lay it out as you want. I'm just making it so VCC's on one side. These are decoupling capacitors. They're generally put in between the VCC and ground. And most of the time, right near the actual part. The closer you put it, the better. So I'm guessing this one here. If you zoom in, you'll see the VCC and ground, so we know it's for that as well. So I'm going to put this pretty much under the chip, because generally you want to put decoupling capacitors as close to the IC, the chip, as possible. Alright, so these are the ones we're going to put in line. Again, we might have to move this. Not a big deal. Alright. So to make things a little easier, I'm going to select group, move everything at once. I'm going to right click just to kind of get them in orientation, then I'll move them around. Same thing with this right here. I'll highlight all this, move it closer so I don't have to keep scrolling over to the left. Zoom in. Okay. Again, you can rotate this if you want the text and orientation different ways. You'll see when you get close to the edge, you'll see this green lined area. That basically telling you, according to the rules that we have set for the circuit board, we're too close to the edge. And that means the board house will might cut into it, but it all depends, you know. So this is why I gave you those files. So if you guys come here, if you have a bigger screen, it won't be so compressed. You'll have these extra options. This is the error rule check and the other rule check, design rule check. So you click on here, you hit load, and you would use the DRU that I gave you guys. I renamed it to default on mine, default DRU, but yours will be Osh Park something whatever tented. So click on that, hit open, and then it'll change the name from default. It'll say Osh Park. Then you want to hit apply and select. Okay, so now if I move that part, if I move the this part close to the edge like I had earlier, it's probably not going to give me, well, it's right on the edge, but if I move this over a little bit, once you get too close, it's going to give you that error. Okay, so let's finish the rest of these off. I know this one is for the sink because the value 200. 10K is for this down here. So as you kind of laying things out, you'll see some of the traces kind of crisscross. So just rotate the part. Okay, so there's our board. So I'm going to show you guys a few tricks. Generally, when you make a circuit board, you want to have like a ground plane, which makes it routing easier and also helps with like noise on the lines. So if you go to this icon here, it's a polygon. If you click on that, you have a few options. New menu options pop up over here. You can do a hatch. The hatch is kind of what you see in flex circuit boards, but we're going to do the solid. But I'll show you both. And the width. The standard width is fine. You can make it thicker. But if you make it thicker, where it makes the connections, sometimes it'll be too thick depending on how, like the chip's legs here. So this is like a good number. I would just leave it at that. So and this is free move, free angle, curved. I just generally do the box, and you just go around the perimeter of the board, and you make sure you go back to where you originated, otherwise it won't close properly. Then you click on that. It's going to tell you what the signal name is. So we're going to name it G and D because that's what we wanted to connect to. So since we did that, some of these kind of will disappear once we hit the rat's nest. So this right here, whenever you move things around and you want the program to kind of consolidate things and put things together, and also when you have a polygon, it'll remake the polygon. You hit the rat's nest. So now you're going to see everything's going to turn red, and anything that's ground is going to have little connections. I'm going to show you. Okay. So everything's red. So this means this whole top area that's red is copper. Red is the top copper layer. Generally blue is the bottom. I think I changed it on mine. You can change it. You can just, if you want to change colors of whatever layer, you can just click on here, layer settings. So I changed mine to purple, but generally it's blue, like a dark blue. But you can change it to whatever you want. So wherever you see these connections here, that means this via is connected to ground. So, and this is based off of this width right here. So if you make it bigger, you don't need to manually write anything. You can just scroll through the common values. You might not be able to get like the 4 here. And as you can see here, we have ground on 2 pins. So these 2 pins, you can see the width is almost the width of the pad itself. So if you go to a higher number, you run the risk of always, like, you might be able to potentially cause a bridge, especially if it's too thick, with the neighboring pins, which are not getting ground. So this is a good width to use. Okay, so I know, like, looking at this picture is like, oh man, the red hurts your eyes. So what we could do here, this option here is the rip up. So this, you can rip whatever trace or segment or the entire trace or the entire board. This gives you the option. It also gives you the option to get rid of the polygon, which is this last one here. So it doesn't delete it. It just gets rid of the graphics, so we can actually see things again. If you want to turn off the grid, you can also, again, you can do that. I like it, maybe it bugs some people. And the traces are going to follow this grid. So if you want like tighter angles, you might want to make the grid smaller. So half of that, the easiest way for me to do halves of anything is I put it on mil, and then I generally like 12.5, and then put it back to millimeters, and that gives me a small enough number where you'll see the blocks just got a lot smaller. So now the traces will follow these blocks, so you have more control and better angles. Okay, so since ground is covered with the polygon, we don't need to run traces for ground because they're really all grounded. But if you want to do the same thing for VCC on the bottom layer, you can. So we would do polygon, and over here, the layer, you would choose bottom layer. And again, just do the perimeter or wherever you want. You can have like a small area. Let me see where's VCC around here. So VCC is generally around this area and obviously here. So I'm just, again, we're on the bottom layer, so I'm just going to go. You can make the polygon any shape you want, essentially. You just got to make sure you always return to the originating point, and that's going to ask us what the signal name is. We're going to put VCC. So VCC is within this polygon, and that's going to cover a bunch of these parts, except on the chip itself, because it's surface mount and it's on the top layer. We would have to create a via. So this is a good example to show you guys how to put vias and carry signals over. So we're going to do the rat's nest so we could see where the via is. Okay. And you can either do VCC, run a trace here, and just go this way, or we can put a via to this ground, this bottom trace. So this is the vias right here. Generally, 0.35 is the standard size. You can go down lower. Most board houses won't go past this, and if you go to this value, the 0.2, you have to pay extra. So generally, don't go below 3 unless you want to pay a little extra. 3 is good enough. So here's VCC. One thing I learned over the years, you don't want to put a via on top of a pad because solder will get through, and this thing will actually suck up shit tons of solder. It can actually like get under the board. So you always want to put it off to the side. So once you lay the via, you're going to have to name it. So we're going to go back to the naming, because right now it's just a via. If I do the rat's nest, you're going to see it cleared up all the copper on the bottom and top. So there's just a via in the middle of nowhere doing nothing. So we're going to click on it, and it's going to ask us the name, and we're going to put VCC. So this is basically the net. Whatever you name the same is going to be connected. Okay, so now if I do the rip up and I click on this, you're going to see now there's a yellow line. The yellow line is the unrouted traces. So the unrouted trace from here to here now exists because we named it to the same connection. Hopefully you guys get this. The via is making a connection from the bottom layer to the top, and since the bottom layer here is VCC, this via is VCC. Okay, now we're going to start doing the traces since we have things kind of lined up as we want. Make sure you choose the top layer because mostly everything is on the top. We're going to start on the top. I like to generally use this one, and my trace width, since you got the chip here, you want to go maybe 254 or 2030 here, 0.2030. You can always click on it and you'll see how thick it is. Okay, so it's almost the same width as the leg. So we can go one more, 254, which is okay. So 254 is good. VCC you generally want to put a little thicker if you can. So we could make that. Let's go to the 4. It's going to look a little bigger, but that's fine. We have enough space. Ignore this line. When you do the rat's nest, it'll all disappear because the VCC on the bottom is connected to this one as well as this one. The program just kind of tries to associate everything on the same layer. And when we do the rat's nest, it just redoes everything so all the signals have the correct or place where it's supposed to go. Okay, so we're going to click on route the air wires again. So here's a few more options. You can ignore obstacles, which sometimes is good, but as a novice, I would not turn that on because you can easily run a trace from here and you're not really paying attention, and you might go over another pad from a different component, and now those are going to be linked and overlapping. So you want this second option here, walk around obstacles, and I'll show you what that looks like. You can also push obstacles. So this one's kind of cool. So if you have a bunch of traces, but you need to get one from, like say you got these two here, and you need to move and get this through, and it's too tight according to the rules that we set using that file I gave you, the DRU, it can actually move the traces around it to give you the space. But I generally use this one here, the walk around obstacles. We're going to go to 254 for everything else. So all right. So I'm going to start with the top here. It's real simple. Again, if you right click on the mouse, you can change the orientation of the traces or whatever part you have highlighted. There's no right or wrong way of how you're going to route this, as long as there's an overlap and it connects. When you have like big areas like this and you have the chips with small legs, I generally like to start from the chip, just so you don't get stuff like this, you know. I like going from the chips. You have nice clean lines coming out of it. Again, you don't have to do this. The boards are going to work perfectly fine. They're going to be made, you know, no problem. But I just like to make things look nice. So one thing right here, for me, that would be an issue, but I'm going to do it anyways, just so you guys can see. This is really close to this pad. When we do it, the DRU check, the design rule check, this might come up as an issue. So generally, you don't want to put pads too close to traces. So I'm going to just Control Z that and do it again and come in a little sooner. It's okay if the trace goes over this green area because these are all connected anyways. Again, the same thing. You don't want to go. You see how this is what the option does, that option that we chose. So it'll go around according to the rules and leave the proper space. It'll go around different objects. But we know we're actually coming over here, so it's not a big deal. We have enough clearance. That's good clearance. Let's finish this one off. Okay, so the whole right side has been routed. That's nice. Okay. Again, like I said, I like to start from the chip and then go to the part. Whenever you click, you're going to put like a stop, and then you can continue your routing from there. So for example, like if I want to come here, I can route this way, then route that way, then route this way. Why would you want to? No idea, but you have the option to do so. I could see something here that happened. I guess I wasn't paying attention. I guess I moved it once I clicked here. So generally, I don't like this. I like nice and straight, you know. And because we made this a little thicker, I don't want that as a possibility of something, especially when it's getting made. It could be an error that the fabricator makes, and you're wondering, why is this shit not working? It could be that these two might be bridged. So I'm using the move tool. Oh, this is actually a good example for me to show you guys the rip up. So if you click on rip up, you have a bunch of options. Connected copper, which means if I click on this, everything connected to this trace is going to be ripped up. For in this point, it's fine, but like in this, if it was this bottom one, if I just wanted to rip up like this area, and this option was chosen, it would erase everything up to where it ended right here. So we're going to leave it on the first one and just click on that. When you click it, it's going to highlight it. I'm going to go back to routing. This time we got it better. So you see how there's like this little nub here? Again, you can leave that there. Nothing's bad about it, but I don't like it. To me, that screams that was a mistake overlooked. So I just removed that little stub there. I'm also going to show you guys some advanced routing options here. Once we go to the SMD, the surface mount parts. So because this trace is here, if you go forward, sometimes it can do that weird routing. We don't want that. So if that's the issue, you can always just go to the move tool, move this one up a little bit more, give you some more breathing room, or we could have just went from behind. There's nothing wrong with doing that. All right, these are easy. Let's push them over. And don't forget, we got the bottom layer as well. I'm doing everything on top, but we can also go to the bottom. So to go to the bottom, you would click up here. A shortcut I learned not too long ago is if you the mouse wheel, the button, if you click it, it'll switch. As you can see, I just clicked it and went from top to bottom, bottom to top. So once you're on the bottom, you'll see the traces now are going to change color, wherever this one is supposed to connect to. And the same thing can be done over here. And then we're going to hop right back up to the top. So one thing I'll show you guys, this will come in handy when we do surface mount parts. So like say you're running a trace and you got a bunch of stuff in the way and you don't have space. So as you're running the trace, if you hit that mouse button, it'll drop a via for you, and then you click where you want that via to be, and now it's purple in my screen. Yours is probably blue. So now we're in the bottom layer, so you can go underneath traces or parts without any issue. And then once you're ready to come back to the surface, you would click on the middle button again and lay the via where you want it to be, and there you go. Little shortcuts. Normally you would have to, if I didn't do it with the shortcut, I would have to click where I want it to be, and then come up here with the mouse, click on top and choose bottom, and then I would drop the via. So by hitting the mouse button, the wheel button, it just simplifies that whole process. So we really don't need to do that. That was just to show you guys an example, because we could just run the trace. Top or bottom, doesn't matter. from here to here, and that's it. So once you think you're all done, sometimes there's like little connections, the unrouted wires, it's what they're called. Uh, Sometimes they're inside the via or the pad, and it makes no sense. Like, why didn't I connect? So once we're all done, you think you're all set. We hit rat's nest, and if you look down here on the bottom, you should be able to see the message rat's nest, nothing to do. So that means that there's nothing that's unconnected. For example, if this wasn't connected and I kind of overlooked it and I hit rat's nest, it would say down there one air wire left. And then if you still can't see it, you don't know where it is, this is when we do the check. So we do the design rule check, DRC, and we would hit the check. And this will give us all the errors that have shown up. So the only one is this air wire, which is the one that if you click on it, it highlights it, and you'll see it's the one that I forgot purposefully. So then you can zoom in, and all you gotta do is just make the connection. Put it on top. And the errors are gone. Sometimes there's intentional errors, like the via, for example, you want to make a castellated hole. The way you do that is put the via on the edge or outside, like half inside the board, half outside the board. Anything that's outside of this board shape is going to get cut off. So this, by you seeing this symbol here, this is going to tell you that that's going to come up as an error. But so we do the check, and again, it gives you the dimensions. If you click this, it'll tell you which layer the error is in too. So layer 1 is the top, and layer 16 is the bottom layer. So since this is intentional, we wanted castellated holes, we would just click on that and just approve. You really want to approve the error? Yes. And then it'll be gone. Again, this is if you're going to be doing castellated holes, this is what you do. You generally put the via in the middle or part of it on the outside, and it's going to get cut. But the program is going to give you an error message, which is totally fine because that was intentional. But if it's not intentional, it'll let you know, and this way you can fix it. So I'm going to put that back, Control Z. All right, so our board is routed. So now there's a few things I like to do. Again, it's all aesthetics for the most part. If you don't like how this is routed, not a big deal. You can put these parts practically anywhere. You just got to run the traces to them. So we're just doing this like what's more practical, so like lining all this up right here. And if you're assembling this by hand, this is probably more practical. You can just put all of them and you can just solder them all pretty quick. So I generally, once everything's, let me get rid of that. Once everything's done, I like to come back and like alter things, make it look better. I generally get rid of the polygon. So one thing I like to do is I hate sharp corners. So this miter option, you have a few options. This option right here, we're going to click on. It highlighted the red dashes, which is the polygon. We don't want that. So you right click on that, and it's going to highlight the board edge. So you're going to click and hold, and then when you move it in, you can give it an angle. Generally, I like a round angle as opposed to the other one. So that's the way I like to do it. If you want a particular angle without having to manually do it, you can put it here. Generally 1 millimeter. You can even do 0.5 or 0.25 or whatever. But I like generally 1 or 2 millimeters. Now, when you click on the part, make sure you highlight the one you want. You click on it, it automatically will curve it to 1 millimeter radius. Again, this is my personal preference. You don't need to do this, but I'm showing you all the options so you guys know how to do it. Okay, the next thing I like to do is I like to go over my traces. I like to see if anything's like too close to one another. Like this right here, this is like, it gives me anxiety. I like to leave enough space where nothing can possibly be messed up in the factory where it's like, oh, this trace somehow bled into that one. Shit happens. It's already happened to me. So that's why I know. Also this right here, like I ran it this way, but it's on the bottom layer. So I can actually move the entire thing over this way. We don't need to really go so far out. Again, total preference. I like to clean up after I'm done because sometimes you route things, you're like, oh, I could have done this better. Okay. So I think this looks pretty good. So from here you can, what I generally like to do, a lot of people don't do this, extra step is I like to make the silk screen as a separate layer, which then I can change and modify and do whatever I want. A lot of people generally move these titles around, and you could turn them off as you need them. So this is resistor 1. You can put it in the center. I generally like to put these in the center. But you'll also see there's the value. So where are you going to put this value? You can put it off to the side, I guess, and then draw a line so you know this is 1K. So I also included a file in the ULP folder. Actually, there's a couple files I included, but I like to do this. You don't have to, I'll show you how to set it up if you don't do it with the ULP file. So generally you would have to move all the parts where you want, and then when we're going to export the parts to make the Gerber files, then you would have to choose different layers, and I'll show you guys that. But I'm going to go with the way I've always done it. I go to ULP. Okay, I have number symbols. This way they pop up at the top. So the Silk Gen is in your, should be in the files, as well as the GLC PCB, and also I believe this one here, this length frequency. So we're going to click on Silk Generator. It might give you an error. Just ignore it. Hit OK. You don't really need to touch anything unless you want to. The only thing you might want to change, it's up to you, is the layer number. Generally, the layers go up to like 50 or 60, and then anything after that is custom. And the numbering makes no difference. There's no importance unless it's already one that's been taken, like layer 1, layer 16. You don't want to overwrite that. So I generally leave it as it is, and I just hit make silkscreen layers. Sometimes it gives you an error about some ratio. It's not a big deal because we're going to fix all this. Just keep hitting OK until it's done. Once you get to this screen here, you hit execute, and you're going to start seeing yellow popping up all over the place. So for me, this makes it much easier to set up my silk screen. I don't know, this looks like a mess. But I know what I'm changing there is not going to affect any of the other layers. So if I go to layer settings, I'm going to turn off the top place, the bottom place, the origins, which is, we don't really, the origins is when the green, and mine is green, yours is probably gray or a different color. That's where you can click to move parts around. Since we don't want to move any more parts around, I'm turning it off, so you can't click it. We're going to take the top names off, and we're going to take the top values off as well. Okay, now if you scroll down, you're going to see there's 2 new layers. The top silk and the bottom silk. Again, you can change the colors. You don't like yellow, you can make them orange. I don't know what the heck happened there. Should have been orange. Oh, think it went all the way down. Let's try that again. Okay, there we go. So you can differentiate if you want to put like the top silk screen orange or whatever other color you want, and the bottom one will be the yellow. Personally, I like the yellow better, so we'll stick with that. Okay. So now, if I turn that layer off, I'll show you guys real quick. There's no more writings or symbols. So that's what was the other layers, the names and values. So now we can edit all of this to our heart's content without messing up any of the original words or anything like that. So you can either, again, this is all preference and your options. You can either get rid of the resistor numbers and just keep the values. You know, if this is like for your personal thing, the resistor is going to cover this anyways. You can. I'll do that. I'm going to get rid of the resistor names and just keep the values. I think we forgot a couple values here from what it looks like. Let's go back to this schematic. Yes, we forgot these over here, which I believe are 1K. Oh, yeah, sorry, I wasn't looking at the chat. So, iMod Systems, the schematic, I looked around for it, but if you have the data sheet of a particular chip, they generally have like a generic schematic you can work off of. I was just trying to find something that would be easy for everybody to easily find or get, but I can get a data sheet and show you what the general, like, they normally have a specific generic one and you can work off of that. I'm sure this one here is based off of a generic one in the data sheet. So these are the 1K also. So let's put the value there. So I guess while we're here, I forgot that. Let me take one of those out. So I guess if we do the error rule check, it gives you a few errors here. So JP1 has no value, and that would tell us, which is okay. That one is not a big deal. R7, which I purposefully just removed, would have given you the error that we forgot that. Since I didn't do that, I've been doing this for a long time, so I tend to not check just because I have enough confidence and experience. But when you're doing this, it's always good to do this ERC, the check, before you go into the board. So let me put that value back. All right, now we can go back to here. You're going to see, obviously, it's not there because we made the silk screen based off of what was originally here, and anything new added is not going to show up. So we can just copy. We're going to copy the 1K into the other places that we missed. So basically these are all 1K. I think there's one more. And now we can start moving these things around. You'll see there's the cross here for the text. That's where you would click to get it. You gotta be careful because if you click on the silk, you can move the silk screen, you know. All right, so those are all set. VCC is good to have. We all know that this is 0.1F, but again, we're gonna keep following what we did here and just get rid of the names and keep the values. Okay. You don't want to put any silk screen over pads or vias because those will not show up when you get the board made. Those will be cut up. Like if I put the 0 here, you're only going to see the dot 1 UF. The 0, which will be on top of the via here, will be cut off. So we don't really need this U1 there. We're just going to move this up to the top, since I want to put this above this as well. We're going to fix this all in a sec, but again, this is steps that if you didn't do what I just did with the silk layer, you would have to move all the original names and designators and values. You would have to move them yourself. But by having this extra layer, you can do whatever, add to it. And also, I'm going to show you guys how to import a logo. As a silk screen. I'm going to put the ground on this side. Again, you can rotate it. If you're wondering, oh, why the rotation, like you want the ground to face a different orientation once it goes sideways, you can just click on here, spin with flag. After you have the whatever highlighted, now you'll see the ground will rotate completely without being in the same orientation. Again, you're going to have to do the same thing for the VCC. Okay. One thing I didn't show you guys, which is a very powerful tool, is this eye icon right here. If you click on it, the info, you can click on anything and it'll give you information, which you can also change certain things. For example, like, oh, I want to make this thicker. So like the width is the width of the of that particular trace, just that highlighted part. Long dash and short dash and dash dot. You don't want that for traces, because then the trace is not going to be complete. It's basically like these line dots over here. You can also name things. So if you want to make this, for whatever reason, GND, you hit that. You want to connect it to ground. This will give you an error because ground is connected everywhere. But if you wanted to name it something completely like a different signal, like this signal here is N money sign 5, and if I put this to N money sign 5 and hit apply, well, can't merge those. Okay, but if you have the via, as we did, you click on that. Here you can change the name. But because it's connected already to the ground to the VCC, it's going to give you the same error. But this is another way of doing things. You can also change locations of things. One thing, when you run this script, it changes the grid back into mil, so you have to go back into millimeters. Otherwise, when you look at certain numbers, it just doesn't make sense. So here's the width that we chose originally, if you guys remember, 0.254. If in mil, it was 10. So generally, I like to use millimeters, and all board houses use millimeters. So here you can change this. So if you click on the drop down, you have a bunch of options, or you can just scroll with the wheel. So if I wanted to make this like super chunky and hit apply, you're going to see just that part changed. Obviously, we don't want that, so Control Z. But if you click on the text, it'll tell you what kind of font it is. It's vector. The ratio is pretty thick. I really don't like it that thick. Generally, I like around 16 to 18. You hit apply, it becomes more more legible. It's not like big fat and smudge. It can end up smudging when they do it. So compare this one to this one. It's subtle, but it is enough difference. So if you want to change a bunch of them without having to click on every single one and then manually changing it to 18, there is this wrench icon, right? This allows you to change numerous aspects of numerous things. So it gives you a bunch of options here. So what we're going to do, we want is the width, not the width, the ratio. Click on ratio, type in the 18, hit OK. So since this is highlighted, as you can see, it's gray. Whatever I click on now is going to change to that ratio. So I click on this, you'll see it change as I click on it. Just click on every single one. If you're like, oh, this is tedious, I have so much stuff to do, not a problem. We can highlight everything with group, but because you have a bunch of stuff, you're going to also choose with group. Like if I do this, it chooses the board outline, the polygon, the traces, and the text. So we don't want that. So what you do is you come over here to the layers and just disable the layers you don't want it to highlight. Once you got your board shape also, I generally uncheck the dimension, which is what the board shape is. This way you don't accidentally click on something and move it. You'll see it'll still have the dark layer of what the board shape is. So generally, once I'm done with the board shape, I'm happy. I uncheck this. This way I don't accidentally click on it, delete it, move it, add an angle I don't want. This way it stays exactly how I want it. And if it's not highlighted here, then we can't choose it. All right, and I'm going to get rid of the pads and vias as well as the bottom layer because I don't want to mess with this this polygon. So they're not deleted. They're just you're not seeing them and you can't check them off. So we're going to highlight everything. You'll see everything is highlighted. We're going to go to the change, the ratio, 18. Okay. Once you have a bunch of things highlighted, if you want to apply the change or you want to move a bunch of things, you have to hold Control and then right click on any of these items and it'll do it all together. Because once it's highlighted and you chose the change and whatever you chose in there and you click on one thing, it's only going to change that one thing. So you have to hold Control and instead of left clicking, you're going to do right clicking. You're going to see a bunch of this stuff right here. If you pay attention, it's going to change the ratio as it just did. So I was holding Control and then I right clicked on this one, which changed everything for all the other ones. You can also do the same thing for size. So if you click back here, the good thing is the last thing you grouped is going to be in memory. So when you click on this again, it's going to highlight everything that I had. So we're going to change the size. All right. All right. It's been a while. Let me go to the information here so we can see. Okay, yeah. So what's the size? The size is 0.99 on this. But this is a decent size, but this is like much bigger, so I want them all the same size. We go to size. There's a drop down here. If there isn't a size you want, if you come to the little three buttons at the bottom, well, let me choose something different. Okay. If you come to the three dots, it'll give you the option to enter what you want for whatever it is, for the drill size, whatever you chose. So we're doing size. We'll stick to this size for everything. So we're going to click on that. Then we hold Control and then right click on this one or any other one. Oh, remember those? You're probably wondering where'd all this shit come from. When we did the silk layer, it basically takes all the text and converts it. So the size that was originally on the test pads, remember I told you guys sometimes you click on it and it clicks on the text. This is what happens. So that text was super tiny. It was never going to be printed. And we made everything the same size. So now that tiny text that was we didn't even see now is regular size. So all you got to do is just go to the delete and just delete all of these texts on the they just popped up on the test pad. Okay. So now that we got everything that we want, I just want to double check, make sure this is vector. Yep, they're all vector. Yours might not be. So if that's the case, just highlight everything, go to change, you go to font, vector, and then do the same thing. Right click with the control. All right, now everything is vector. We want vector. And the reason for that is, as I said, whatever you set up in the silk screen is going to show up exactly how you have it on here in the program. If you use the other ones, then they might use a different font. It might look different than what you wanted. Okay, so now we can turn the layers back on. Just the pads for the most part, because we want to orient the silk screen based on the pads. So this one here, you don't need to do like I'm doing. You could do it exactly, I mean, however you want. If you want to put it on the side, you can do that. If you want to move this closer to that, you can do that. It's all up to you. Like some people might not like this, not a problem. You can come here to the eye, click on that, change the size, make it smaller. That's too small. You want to stick to something around 6, no smaller than that. You can see what 8 looks like. 8's pretty good size. So I know it seems like I'm spending a lot of time doing this, but whenever I make a board, I spend tons of time with the silk screen because I want it to look good. So whoever is working on it knows what's what, you know. And if you plan to sell anything like this, you want it so it's legible for the customer. They know what's what. If it's for yourself and you don't care, then that's fine. So this is a decent size. Come on. If you put it sideways, you can see that it's going to kind of overhang the board. So you can either move this a little closer and then move this in, or leave it sideways as I had it. Probably put it all this way so it's a little bit more universal. Okay. You guys are probably wondering, oh, what the heck is he going to do with this one? Well, you can put it this way, or you can put it off to the side and then kind of like run a line. So you go to the line tool here and choose the layer you want and the kind of how you want the wire. You know, this one works good, this one works good. So generally, if it's something like that, I'll like underline it, click. Oh, still, you notice it has a little bit of a curve there on the angle. It's because I forgot to remove the radius. So generally, just put that back to 0, hit enter, and now you got the sharp lines. And there you go. So now we know this one here is this one here. Okay, we're going to do the same thing with the output. So we're going to change the size. Might as well change that as well. I'm just being creative. Again, it's your board. You do whatever you want. Okay, we'll give this, where's the, okay, right here is the text. We're going to write whatever it is we want to call this thing. PCE, RGB, amp. And we're in the top silkscreen layer, which is what we want. So generally this, we got all this free space up here, so we can increase the size, make it bigger. There we go. Then hit escape to get out of there, and now we have our board. Looks good. And so you guys want to put your logo on here. So I included a generic logo. I just found that on the internet, some generic crap. We're going to use that. But there's a few things you need to do, unfortunately, to get it to where you can import it. So if we're happy with what we have, save. And then it's going to tell us what you want to call this. So I'm just going to pull, PCE, RGB, amp. Save. All right. After you made the save, it won't ask you that anymore. Every time you click save, it'll just save it. So we're going to turn off all these other layers because the logo always pops up at the origin point. The origin point is right here. This is 0, 0. Coordinate 0, 0. So, and the import is always like line by line. So we have to use the group tool. And if there's a bunch of things in the way, when you group it, you're going to grab these things as well. So we're going to turn off the vias and the pads and the top silk screen. The bottom can stay because we don't have anything down there yet. We're going to put the logo on the bottom. So if you look at the file, yeah, I got a lot of crap on my desktop. Okay, so this logo here, it's a JPEG file. Eagle only accepts BMP. So you're going to have to right click, edit, it should open up the paint. We can crop this a little bit too, so just get it to just what you need. Hit the crop. Now, it only accepts monochrome BMP files. I don't know any other programs, even the fancy ones that save as monochrome. I know Paint from Microsoft does. So you click on File, Save As, BMP, and then here in the drop-down, you would hit monochrome bitmap. Then you hit Save. It says, are you sure it's going to reduce all the colors down? Yes. It's going to be black and white. That's all you're going to get. If you guys have like fancy logos with gradient and all that, you can kiss that goodbye. It's normally solid unless you have like a bunch of little dots, which would be the gradient. But yeah, this is the only way that I've been able to do it. And it's probably a different program or different method, but this is the method I've always used. So I'm showing you guys how I do it. So now we have a new logo BMP. So let's go back into the board. Go to the file. And we'll go into import and then bitmap. It's going to give you all this crap. You guys can read it if you want. Just hit OK. Okay, so I'm going to go to where that is. Eagle schematic tutorial. Here it is. So we hit open. And you choose the colors from the file. So we want the black, obviously. You hit OK. Now, this is what I've always done. You go to DPI, which is going to change things to inches, which is fine. We'll just change it back. It's going to go to layer 200. We can make it go to layer 122, which is the bottom silk, and that'll save us a little bit of work later. Unless you already have stuff on the bottom silk, then you might want to just leave it as it is, and we'll just change it over to that layer. But I'm going to put it 122. This is the important part. Now, depending on the size of the logo, let me see. if it shows right here, it's 261 by 224, so it's not that big. So I'm going to start off at 1,000, the DPI. The lower the number, the bigger it is. I want it big enough so where it's going to be in the middle, more or less, of the board. Hit OK. It's going to pop this up. Hit Run Script. Okay, so if you're happy with this size, I'm not, but if you are, that's fine. If you're not, just highlight everything and just delete it. And do it again. Import. Depending on how complex your logo and size is, and if you don't have like a really fast computer, this can take a couple minutes sometimes. Let's try 600. Okay, I'm already liking that. That's already a much better logo. So, for whatever reason, whatever you import, if you zoom in, this basically says where it came from. There's this text. It's part of the import. So I always delete that. We don't want that for our silk screen. Okay, so now we don't have anything we can choose besides this logo, since we turned off all the other layers. Just highlight it, go to the change layer, and we want to go to the 122. Oh, yeah, the second time we didn't change it, so it went to 200. That's why. So once we have it highlighted, we're going to do the same thing. Hold Control, right click on any part of this logo, and it's going to turn it to the bottom layer. It was yellow, but because we ran that script, it changed the color. So we're going to turn it back to yellow, or whatever color you want. You know, we can make it this purple, which is what it is right there, or this light blue. Let's go with the light blue. The fill style, I like solid. Okay. Okay, so we want to put this on the back, so we have to invert the logo. We click on the group again. Okay, it's chosen. So right here is the mirror option. So we hold Control, right click. For some reason it doesn't seem like it changed. It's supposed to flip it backwards. Okay, there we go. So now it's backwards. We're going to highlight it again so we can move it. You want to make sure you always move your logos with the group, because if I zoom in here, you'll see everything is single lines. So if I choose the move option and like, oh, I'm going to click on the logo, you see I just clicked on one line. So you don't want to do that. You want to select it as a group. I got it in the center. I think that's pretty good. So we can turn some of the layers back on. Let's turn on the pads and vias, the top layer and bottom layer. We can leave the dimension off. You can turn on the top silk if you want. Okay, so let's say, for instance, you have something like this. You're like, oh man, there's way too much shit going on. It's like messing you up. There's a few options up here. You can turn this into single layer mode. So it's only going to highlight the layer you want it to highlight. So if you're on the top layer and you have a bunch of shit on the back, you can just choose the top layer, hit the single layer mode, and it's only going to show you the top layer stuff. Everything will be grayed out. So let's say you want to put stuff on the back. Remember, everything is going to be like reversed, mirrored. But if you want to just work on the back, you can just choose this option here. It's going to flip the board. So if I take out the top silk because it's interfering, you'll see that this right here, you can read it. Where if we didn't mirror it, it would be backwards. And you can easily see that by clicking on the flipboard. So if you're working on multi-layer board, like something on, you're gonna put a bunch of parts on the back, it might be a good idea to use this to flip the board so you can start layering or routing things on the back. Okay, so generally I leave the top silk screen on and I turn off the back because I'm more concerned about what I'm looking at. All right, so hopefully you guys learned pretty good up to now. It's like it's been a 2-hour run. I'm gonna take a quick break because I'm gonna get something to eat. So stick around. I'm gonna come back and I'm gonna show you guys how to do the SMD and how to do the special traces for when you have like high speed signals like HDMI, for example, or RAM and certain things that have to be all the same length, you know. So I'll show you guys how to do that. Comes in very handy if you're doing anything that involves data signals that all need to be within a certain spec. Let me just, I'm going to look up something real quick for a data sheet so I can show you guys where you can get the schematics for whatever chip you want to be working on or with. All right, so I'm back on the Snap Magic website where you can get all the files for the libraries. They also have the data sheet, so we can click on that and there should be a schematic in there. And here it is. So usually it's in the beginning, sometimes towards the end. So this is like a very generic one. See if I could zoom in. Yeah. Okay. So this is the generic one. If you compare it to this one, it has a bunch of extra stuff. But because this one is tailored to the PC engine. So it has, you know, this resistor divider really, and it has the capacitors here to filter likely some noise or interference, buffer the signal. Then you have the output here, the 75 ohms, which we have, but for some reason this one has a 200 ohm, which I'm pretty sure they followed the schematic of the data sheet. So this CVBS, which would be composite, or the sync, they're running it a little differently for the PC engine. But this is generally where you get your schematic, you know. You might have to make some changes. And then, like, for example, like disable and bypass, doesn't give you a lot of info on exactly what to do with it. It does on the data sheet. You would have to like scroll down and read it. And it should tell you what to do with it. But this is one of those data sheets that has quite a bit of pages, lots of information. So right here it tells you logic high disables the part, so logic low, which is why if you look at this here, you'll see disable is connected to ground. So that's logic low. Logic low keeps it enabled. The pin cannot be left floating, which means it has to be connected to either ground or voltage. Okay, so this is where you would get your schematic, is usually from the data sheet, you know. Unless you could find one like I did that is already done for you, but it's just a schematic, you know, you can't do anything with it. So you would have to um, make it like we did. So we made it in Eagle, and now we made a board out of it. So we got the picture, we just essentially copied this and tweaked it the way we wanted it. You know, let's go back to the board. So I use like these kinds of pads, but you could use smaller pads, bigger pads, the only one layer pads, the general ones like that rectangle that I showed. You don't need to use through-hole components, but I just did this because some people might want to use this information to make their own little boards for themselves or their mods, and this might be easier and cheaper for them, you know. Okay, so one thing that's going to change, so we're gonna change all of these parts into SMD, surface mount, including the pads. So here's one thing that I don't like about Eagle, the newer versions, the older ones that didn't do this. When you change a part, if it's been laid out here already, whenever you change a part in the schematic, it'll kick it off the board and put it down here. I don't want to do that. I want the parts to generally be in the same location, and then I can move them. So two things you could do. You can go to change, and I believe it's lock. It's not showing up here. We're gonna have to put the origins back on, right? So here's what you do: you put your origins back on. You click the information button, and you're gonna have to click on every single one. And there's this little box here called lock. So you can click on that, and you'll see that the plus icon now is an X. So that means this part can't be changed. Well, it can't be moved, or any other aspect of it. It's locked. So there's this up here has a command line. You can actually write commands. If you go put help lock, I don't know why that's a small K. It'll actually bring up another window, and this is where it gives you all the options. So we're just going to write lock, allows to lock objects by left click. Lock all objects is lock in the asterisk, which is what we're going to do. And then to unlock is the same thing, but we put a minus. So we're going to do lock space, then the asterisk, you hit OK, and now everything is locked. Nothing can be moved, which is what we want. And the reason for that is, as I said, once we swap the parts in the schematic to surface mount, it generally kicks it off this location. I want to keep them more or less this orientation as we have, and then we'll tweak it as we need. So now we go back to the schematic view. All right, and we're going to replace. We're going to we'll replace the test pads while we're here also. We'll do like 17 rounds, maybe square. Yeah, we'll do square. So I just click on all the current test pads. You're going to get this error, unfortunately, for every single one, because it tells you to run. Whenever you make certain changes, it tells you to run the DRC. I'm going to leave this one out just so we can have a quick look so I can show you guys. So this is what the size was originally, and this is the new size now, the surface mount pads. A lot of times I do that. I go back and forth to see sometimes like, oh, how big is it? Okay, so we replaced the pads. Now we're going to replace the components. So we're going to go to resistor. And we're going to go to the RCL here, the US one. If you scroll down, you have a after you get past this right here is the surface mount stuff. You can click on it, it'll show you. So generally 0805 is a very good size. It's big enough and small enough where most people have no issues soldering it. So we're going to use that for this tutorial. So I'm going to click on every resistor. It's going to give me the same bullshit. Okay, now we're going to go back. We can just hit escape. We'll bring us back to the menu. Generally it does. This time it didn't. Just hit the replace button again. We're going to do capacitor. Okay, we're going to go back down to RLC. So some of these, like I said, I believe it's this bottom one for me is my own modified version, but I'm going to stick to what generally you will have. So we're going to use the non-polarity one. We're going to go to the same size. So 0805. There's actually two versions. One is K, one is without the K. So the K, it tells you right here like a reflow solder. I think this is for reflow ovens. This general one is more than good enough. They generally, these footprints, they give you more than enough space to lay down the part and have solder. So the part will kind of sit here. You'll have like a little bit of pad exposed so you can add the solder. Whereas if this right here, they would have solder paste and then the part would lay on top of it. We'll stick to this one here. It's only 5 anyways. Yep, gonna give us the message. Okay, I think we covered everything. Let's go back to the board and look at it. Yep. Oh, just a jumper. But the jumper we can keep that way because unless you guys want to do a jumper where we solder 2 pads together, let's take care of that as well since we're at it. Okay. Let me see what they have for default. Any surface mount stuff? Oh, yep, we got this one. This is nice generic one. Perfect. The symbol is going to change, so it might give us an issue here. Yeah, the old version can't be mapped. Okay, not a big deal. So sometimes you get stuff like that where the icon does not match the one we used originally. So instead of replacing it, we're just going to add it. Add the part, and then we'll just delete the other one. And put this in its place. The reason we have those junctions there is because where I placed it, I had a little bit of each pad, each trace. So we can just delete the excess. Move that back just so it looks nice. Okay. See, because it's a new part or because, yeah, new parts get added outside the board. This would happen to every single part here that I just replaced. It would be all outside the board and I would have to remove everything. Very annoying. Okay, so now we need to unlock everything. So we're going to put lock, space, the minus or dash, and the asterisk, and hit OK. And now everything is back to the way it was. So now I can actually move this. Put it over here. And if we zoom in, you'll see the silk screen is kind of like on top of where the pads are, so we can't use this anymore. So what I'm going to do is I'm going to essentially, everything here is 1K, so I'm going to consolidate everything. So we got this X over here. This indicates that this was connected to the bottom, but that connection's gone, which was the via of the resistor that was there. So we got two options here. We can redo the entire process, or we can just fix the traces. I would rather we just redo it. So we come here to rip up, and this is going to rip all signals out. We just do that, everything's gone. It's going to ask us, are we sure? Of course we're sure. So the orientation is good where we have it, so it's not a big deal if we got rid of it. It's going to be pretty easy to route the stuff. Alright, so most of the stuff's going to be top layer, but there's going to be a couple that we can go down. So we're going to use that method I showed you guys by clicking the wheel mouse button to create a via so we can go on the bottom layer. But first I'm going to fix this as well. I'm going to move just one of them because, like you can see, these are all 75, so we can kind of just put a border around it with the silk screen, and we know these are all 75 ohms. And the rest I'm going to group it and just delete. Might be a good idea since I don't really see us moving much right now. I'm going to turn off the origins just so I don't highlight the actual parts, which will highlight the pads. I just want to highlight the silk screen. Alright, once that's done, highlight, you can hit delete. Yeah, that's gone. We're going to do the same thing here. Delete. The other ones, well, these aren't too bad. They have the outline. We can just get rid of the stuff in the middle. I actually get rid of all this as well. Okay, I'm going to move a few more things like this. Move it over to the left because I plan to delete this. Okay. So, to make things aesthetically pleasing, we can draw some squares around this. I generally do, because if you have a bunch of them like this, when you're looking at the program, you know that they go across. But for anybody else, it could be up and down, and obviously that's wrong. So generally I like to put some kind of border around, just so the orientation is no mistake, that it goes across left to right instead of up and down. We can also move these things closer, because now you'll see that we have a bunch of even more empty space. So we can actually condense this board quite a bit and push everything over to the left. But if space is not an issue, then You don't really need to do too much. Okay, let's turn back the origins on. This way we can actually move individual parts like these pads. Yeah. Let's put this back to millimeters. It got all wacky once we did one of the scripts. You can just put it back to mil 12.5 as I had it originally, and put it back to millimeters, and there's our nice small blocks. So I'm going to make this a little bit more aesthetically pleasing, maybe how I would do it if I was doing this for myself or as a product. As you can see, the SMD pads, you have a lot. They don't take as much space as the vias. So when you want to compact something, you always want to go the SMD way. Yeah, you can move this real close. Same thing with this. I'm going to turn off the top layer because I want to move this polygon. Well, we can probably bring it up a little bit. The intention is to move this entire area here over. Since we're trying to consolidate the board, we try to move things as close as possible when we can. If you're doing this by hand, it'll be kind of a pain in the ass. It's probably better off if this was like with a stencil or a machine when you have like a lot of tight parts. This jumper, I'm probably going to get rid of this. I'm pressing delete. Once you have something highlighted, if you hit delete on your keyboard, it will get rid of it. Okay, now that we got those, we can push these closer because there's no reason for us to have that huge amount of space there anymore. And since we're going to shrink the board, we need to turn back on the dimension, because the dimension is the board outline. Now when you have curved edges like this, you try to move it, it's going to get all wonky unless you either take out the miter. So if you put it back to 0 and you just click on it, it'll go back to that right angle. But you can also just make sure you highlight a little bit in past the curve here, and then it'll maintain that curve as you push it in. Okay. It's okay if this is outside the board edge, because it'll only show the copper while in the board. So if I hit the rat's nest, you'll see it won't go outside the board unless you happen to have a ground pad somehow sticking outside. Like if you did a via, you want it to be castellated, and you put it half inside the board, half outside, then it'll show. So it looked like a little glitchy, but it's not an issue when you send it to get made, because the board house is just going to ignore everything outside of the board dimensions, the edge. So we put this kind of in the middle to make it look a little nicer. So if we want to imitate the same thing we did over there on the left side, might as well as do that. So we're going to have to space it out a little bit more. As you can see, when you move things, when you have the polygon, it screws it up. So instead of you having to hit rat's nest all the time, I generally just remove the polygon and then put it back on when I'm all done doing what I'm doing on the board. Okay. So now I'm going to move to the top silkscreen layer. I'm going to turn on the line, and I'm just going to draw a box around all of these. All right. I'm going to move this in a little bit. Okay. Go back to the line tool, and I'm just going to go across. This way each capacitor, or resistor rather, each resistor, you can tell that it goes in this box going across instead of up and down. So if you didn't use my script to make the silkscreen layers their own layers, you would have to choose wherever you have probably like the the top place or top value. You would have to choose that layer and then make these lines with the line tool on that layer. But doing it the way I do, in my opinion, is much easier. I can manipulate this all I want and not have to mess with any of the other stuff. But most people and most other programs, everybody does it the way I just explained, by using one of the other layers and just build on that. Anybody who's watching has any questions, just type it out and I'll hopefully get to it. So some of you might be wondering, what is this red line around? So this is basically the keep out area. So if you put anything, a trace or another part, and it overlaps, you'll get a warning about that. It's perfectly fine if you get, you know, in here, but the part just has that. They like to give it some clearance, essentially. All right, there's ground in VCC. We could leave it there, or we could also move it off to the left. I'm probably just going to move it down. See, when you click on whatever test pad, the silk screen doesn't come along with it. You got to make sure you choose either group it, you know, but you got to be careful. If you grouped it here, you can easily grab this polygon, which we're going to end up extending anyways. Okay, so if you guys remembered from the first half, this polygon on the bottom is a spot that is VCC. Since we don't have any more through-hole stuff, we have to add vias. So there's a few ways we can do this. We can put a via on the side of every pad that's VCC, which is only like three or four it seems. Or we can put a via here, and then we'll just, from there we can make the connections. That's also a very viable option, so I'm going to do that now. I'm just going to put this here, and probably one here, and where I had it originally. We have to go to the name and name each one VCC. Okay. Ground, we don't have to worry because the entire top layer is ground. But I am seeing something here. So one side is ground and the other side is a signal. So I'm going to move it so the signal pad is on the same side of the trace, because the entire board is ground. So if this is ground, if it's on this side, it's not a big issue. It might be a good idea to put some border around this jumper. Okay, so now we're going to start routing. All right, we're going to go. I like this. I don't like right angle traces. I like to have like angled 45 degrees or whatever. We're going to make it 0.254, quarter of a millimeter, like last time. Just excuse me, I gotta clear my throat. All right, and we're essentially gonna wire everything up like we did before. There isn't too many things I could see where we're gonna need a via, but if we do, I will do it and show you guys. All right, I could see where we're gonna have a via, quite a few actually, because these pull down resistors on the side, which is on the top and bottom here, I believe this one connects to this one here. So if we put traces going across, I can't put this going over this. So I'm going to have to put a V and go underneath and then pop up the other side. So I lay the trace down, then hit the mouse button to lay the via, click it, and then we're on the bottom. I'm going to put it in line to where the trace is going to go, so it's going to catch it directly in line. This one can connect up here, as they highlight where the trace needs to go, which parts are connected. So I'm going to do the same thing on this one. Okay, so this is the one that would get the via. So this one, we could use a via if we wanted to, but we can route around it. And we're just going to come out the back. Oh, there's another via here that we forgot, but I mean VCC. We can just run a trace. I know it's hard to see because it's highlighting the polygon beneath, so we can make sure that's removed. And now we can run a trace and actually see the damn thing. One thing you got to be careful is you can cut off ground or other copper planes by routing traces. So for example, like there's plenty of space in between, but if this is more like compact, like almost on top of one another, and this trace is probably closer here, ground and a few other things on top, ground would be isolated. So you didn't have to run a via underneath to where ground would be somewhere else to carry that signal to that isolated part. But because this is very open, this board, you don't have that issue. It's when you start getting smaller boards and very tight areas, then you have to be aware of you cutting off certain signals that's on the planes. But this is not the issue, but I just wanted to bring it up as I'm doing it. I'm like, oh, this, if this was more populated and smaller, things were closer together, could have blocked off these two grounds right here. And you would have to run a trace and a via to another ground location. All right, so we can do you see how this one is kind of, depending where you move it, it can start getting all funky with the trace. So maybe the end, money sign 15, maybe we can move that up a little bit more to give this pin some more breathing room. Oh, here's a great example of we can run a trace on the bottom of the board, or we can possibly cut through because we have plenty of space in between the silk screen. So you have options. Other option too is you could do is just push this off to the left, bring this jumper over here, and you can have the jumper closer to the board and just forget this entirely. Yeah. It's good to have options, and we have plenty of them. For now, I'm just going to leave that there. But, you know, as I said, you have the option. So, that actually comes over here. I didn't realize, but not a big issue. We can click here, and then you can just run it straight up, and then connect that. Board's almost done. Okay. So, as I said, if we think we're done, we're going to hit the rat's nest, and it'll tell us down here if there's any thing we missed. Nothing to do, so that means we are good. The only thing we probably need to do is, because we shortened the board, we didn't move the silk screen on the back, so before we finish, we're going to have to move it over as well. So let's turn off the top silk and put on the bottom one. As you can see, it's a little off. Also going to turn off the other things. Turn off the vias as well. This way I can just choose this and move it over. Okay, once we're happy with how we have it, we just hit save. Always save, otherwise you're going to regret it later. If the program crashes or something happens, all that work goes down the drain. So I'm going to move the... okay, here's a great example. I was saying about the curve. So this is a curved edge. My mouse is on the fritz. Where it has the curve here. So if you click on the flat part, only that part moves. The curve stays. So easy solution. You can just go on the miter and just straighten all the edges out. I guess those are not moving. And we can also group them. But, well, here's something that I kind of forgot. This will come in handy. So these are all the layers that are highlighted. So we can move everything within these layers. If you just click on the top silk, you should be able to click only that. And nothing else will get chosen. So that works pretty good. Kind of forgot about that. Well, it's a hack job. I'm just gonna redo it. Keep it the same width as the previous silk. Whoops. I forgot to change the layer. I was just about to make a square with the top copper, and that would have shorted out everything. You know, again, you don't need to do this, but I am picky with my boards and my silk screen. I like it to look proper. Okay. So now we're happy. We're gonna hit save. Okay, so now you're thinking, all right, we got the board. How do we make Gerber files to export this so we can get the board made? Okay, so then that's when we come over here to the CAM processor. Click on that. Load the job. You click Open CAM file. I already included one, which is the one I generally use here, which is this Oshpark 2-layer new. So you should have the exact same one. Click on that, and that will set up everything needed. The slots, I set that up on layer 46. What this is like, say you have HDMI socket, USB-C socket, and it has the legs. Generally, you don't want it to be a circle. You want it to be kind of a slot. So so you would draw a polygon, which I'll show you guys real quick, in this layer, and curved. So you have like a curved slot, like an elongated curved slot, and it'll be plated. So that means it'll be connected to the top and bottom. I always have that on there because you never know if I have a part that requires it. If it doesn't, you'll see it's completely blank. So just right click, delete it. There's nothing on the bottom to expose, so the bottom solder mask is empty. Top solder mask is all the pads where the paste is going to go, or solder. Well, you know what I mean. Bottom paste, top paste. Okay, the silk screen. If you didn't do my method, you would come over here and go to wherever it is that you put it, whatever layer you would use. So maybe it might be names, maybe it might be top place or values, whatever that is. You would click and then hit OK. But since my bottom silk screen is 122, that is the one I'm using. So this file is tailored to the way I do it, but you can easily change it and then save it to how you want to do it. So here's the top silk screen, the bottom copper. This is the two traces we ran, and here is the VCC plane. The top copper and the board outline. So once that's all said and done, all you got to do is process job. It's going to give you the option where you want to save it. It saves it generally where the PCB files are in the schematic, which is the folder that I made the project. So we're going to hit save. Once it's done, you can hit open folder, and you're going to see we have this zip file. It's already zipped for you. All you got to do is upload it to whatever website. It's got all the proper Gerbers. Okay, it's going to ask me if I want to save the file. I'm going to say no because I deleted my slots. I like to have that there just in case I need them. Okay, so let me see if I can find an elongated. We can use this. This is fine. So I'm going to show you guys an example of the elongated slot for the mill that would have like it would be plated, so it would just generally like a via of some kind. I'm gonna make it big. Actually, you know what? I'm gonna put a test pad that is already elongated. Okay, we'll go with this 17. We'll do 13. 13Y. I'm just going to place this wherever, just to show you guys an example. Okay, so let's pretend this is the one of the mounting pins of. Oh, got to highlight everything now. I think I turned off the top origins. Okay. So generally what I would do is I go to a polygon, choose the milling layer, the parts libraries I make generally already have this included, so I don't have to manually do it per part. But if you haven't done it, this is how you would do it. Yeah, this is fine. The width. I generally go from like the center. I want to catch the edge of this cutout, this hole here. Okay, so now we got this. So it would generally be the square, but we don't want it square, so we have to miter it. Let me see. Let's try 1 millimeter curve. That's too much. It's already going past the middle point. Let's try 0.75. Sometimes when you go too far, it won't allow you to fix it. This time it did, which is good. Okay, so you can see this one has more of a curve than this side. It's like all oblong. It's weird. Let's try 0.5 millimeter. See, I can't click on either one. When that happens, you got to Control Z to when it was straight. Okay. So that looks pretty good. You have more or less an even amount of the green going around this. So this blue area would be milled out and it would be plated. So the top pad here around this via would be connected on the inside all the way to the bottom of the via. So it will connect the two layers on top. So that's what the milling is for, and that's what that option is on that pad, on the files when you run the cam. So since we don't need this, I'm just going to delete it. Okay, so let's say you want to get this board made in JLC PCB, and they're going to assemble everything for you. I have a file for that as well. So JLC PCB, they're kind of picky with how their file structure is for the assembly. So what you would do is you go to the ULP, and if you have the files that I included, you got this JLC, PCB, and BOM CPL manager. You click on that, hit open. It's going to ask you the top layer or the bottom layer. We only have parts on the top, so we're just doing the top layer. It's going to ask us the folder. We're going to use the same folder as before. Okay, and now if you go to that folder, which I don't have open. Okay, so now you have these two files right here. So you're going to need either Excel or one of those free programs that edits spreadsheets. So the CPL is basically tells where the pick and place machine is going to put the parts. You don't really need to mess with this. The BOM is the important part. So we need to open this up. Okay, so everything is compressed. I hate that crap. So you got to kind of push it off to the side. Okay, so these are the test points. Test points is not going to get populated, so we can just highlight that and delete that entire line. Now, where you got to do some work is this SJ1. We need to delete that because that's not a capacitor. So what we got to do now is get the LCSC part numbers. So let me get the website open and I'll show you guys. This is the website where you check the parts. I'm going to push this over to the right window and I'll show you guys. Okay. So looking at the parts, we need a 0805 capacitor. So we just can look up the part number here, or the value rather, 0.1 UF. Then it'll give you a bunch of different capacitor types. We want the multi-layer ceramic. And we choose the package type 0805. Let's scroll down a bit. It should have, you can just write it in, 0.1 UF. Well, actually, you can search within here. Okay. So all of these here is any one of these you can use. So generally you want to look at the price and you want to look how much stock they have. You know, 149,000. I am pretty sure that's good. And it's not even a penny. It's like a third of a penny. So we're going to use this one. So what we do is we click on it. It's going to give us the JLC PCB part number. We just copy that. Come back to our file. Over here, we paste. I generally paste up top. Okay, now we're going to do the 1K resistor at 0805. Alright, so go to all components. They have resistors. Okay, so we want the chip surface mount resistors. It's going to give us the option here at 0805. What the resistance is, we want 1K. Sometimes they have, oh, there it is. They have weird numbers. My mouse is acting up pretty badly. I need to fix this wheel. Okay. As you can see, it's like 1.01. If you scroll down a little bit, I thought I just saw 1K here. There it is. 1K. Okay. Always want to hit in stock. Okay. Set apply. And now we have some options. So this is not the cheapest, but it has a good amount. This one seems much cheaper, and there's a decent amount. So either one of these two, we'll go with this one. It has more than what we need. But in case you think, other people might use this particular part when they're ordering, so it might be a good idea to go with something that has more inventory. Okay, next one is Next one is 10K. Make sure we get rid of the 75. All right, this one's nice and cheap, and there's plenty of them. And I'm assuming this is correct because that was the first one we started off with. So now let's see if they have this chip. Sometimes they do, sometimes they don't. JLC PCB, it's kind of a gamble what's in stock with them. All right, we have a few options. Actually, this is the only one that's in stock, so for 40 cents. Okay. Same footprint, the TSOP 14. So we're going to copy this, put it here. Now we save. It's going to ask me a million times if I'm sure that's what I want to save it as. All right, so now we're going to open up JLC PCB. I'm already signed in. So we're going to go to Instant Quote. Here we're going to add the Gerber file, which should be at the top here. We add the zip file. It's going to upload it, and we're going to get a view of what it looks like. And then we're going to choose the parameters. Again, this is all based on what you want Okay, so how many boards do you want? You want 5 for $2? Yeah, that's a pretty good deal. 10 for $5. All right, then you got to choose the thickness. I generally, depending on what it is, I generally go for 1 millimeter, and the color. Color will increase the price. So if you don't keep it green, you're going to pay more money. So you want black, for example. It didn't change, which is good. It just takes a few more days to process. Then you have heat assisted something layering. Basically, it's instead of having the gold pads like here, they would all have like a layer of solder on it. Generally, for cheap stuff, this is great. If you want the gold, which is the ENIG, you're going to see the price is going to increase quite a bit. So, and the lead free also is going to be more expensive than the leaded. Leaded solder melts easier and just works so much better. Leave it as this, unless again you need the gold plated for whatever reason. All right. The vias are tented, which means if they are below 0.4, the hole, which I will show you guys real quick. I think I explained this. When you do vias, you can set up how big it is. So as long as it's less than 0.4, the solder mask will cover it up. So these won't be exposed. All of these little vias, they'll be covered by solder mask. That's what tinted vias means. But since the file output that I use and the one that I provided everybody has that already built in, it's going to cover those vias unless they're bigger than what I just told you. If they're bigger than the 0.4, then they won't be covered and they'll be exposed. I like to cover my vias. There's no reason to have them exposed. So you can just leave it tinted. Confirm production file. You can leave that alone. Remove order number. They charge for that. You know, generally, like it gives you an example right here. It'll have some number somewhere on your board. That's your order number. I've had somebody from Mexico try to use that number to order boards I had from a fabricator made. So it's up to you. If you don't really care if it's there, I generally don't. But yeah, it can be easily tracked back to whoever made it, and they can look it up and remake that file. All right, so just leave that alone. Gold fingers, we're not doing gold fingers. Gold fingers is generally like a game cartridge, has the long fingers at the bottom. If you say yes, then it'll give you the option for the chamfering, which is so it's not like it's a straight board. You know, it'll insert into the slot better. We're not doing any of that. We don't have any castellated holes, which if you did, you would tell them how many edges have it, like which side of the boards, and that adds to the cost. Let's say we have one edge. See, that already added $36 to the cost. So if you're gonna use them, you're gonna pay a bit. Edge plating. I've never used this, but I'm sure it costs money. Let's see how much it costs. Well, I guess there's nothing there. All right, so we're gonna go to PCB assembly. Okay, and that's gonna already add a little bit of cost. Not a big deal. We're only doing the top side. If you had stuff on top and bottom, that would increase quite a bit. And that would add more cost to it. So tooling holes, just leave everything to JLC PCB. Confirm parts placement. It's always good to have that. Photo confirmation, if you need them to take a picture to show you. I generally don't. Conformal coating is they put, it tells you right here. Conformal coating, they'll put acrylic-based coating to protect the PCB and components from humidity, dust. For most of the stuff we make, we don't need this. Packaging, it's usually in an anti-static bubble. Now, these all cost extra money. Just be aware of that. So, like, this is the standard. But if you had like a flex PCB or even this would be an option you can choose. So this is the low melt solder, and this is the standard leaded solder. We'll stick to the standard. Board cleaning, bake components. This is, if you have some components you want to make sure there's no moisture, this is a good option. But this is more likely for people who do some high-end stuff with very specific components that are prone to failure because of moisture or temperature or whatever. This is good if you have like a bunch of little boards, and because they usually make the boards in panels, but this costs extra, so be aware of that. And add paste. I generally don't do that. Like if there's nothing there, it's because I don't want it to have solder. Okay, so once we're good, we hit confirm. You don't need a stencil, so now we can load up our BOM file and the CPL file. So this is telling us that the CPL has all of these test pads. So we can just continue. We're ignoring them because we're not putting anything on there. So now this is going to tell you how much of each part for the 10 boards that we're going to get made. So 60 of these, 90 of these, and it tells you how much each part total is. So it's actually not too bad. Now here you have the sometimes the parts don't line up properly, so you have to fix them, but this doesn't look too bad. So the capacitors are in the right place, those are right. Sometimes you see this, just ignore it. They know what they're doing. They don't have the 3D model for whatever reason for resistors, so they'll fix that. This is important. You got to know where the pin 1 is, which is marked by this purple. So if we're unsure, we can go back to our board and we'll see that the silk screen is right here. And if you zoom in, it should say right there, pin number 1. Let me get this crap out of the way. Right here, pin number 1 is top left. So when we go back to the board and we see the purple, we know that's that. Because if it wasn't, then you would have to like rotate it. But if we saw that, then we know, okay, this is oriented incorrectly. So you would have to rotate it so that the purple is pin 1 is in the correct location. Once that's done, you hit next. And then they give you the price. What's it going to cost? So this is going so to have 10 of these boards made is about $38. It's not include shipping. You have to, this is for customs, so you have to put this crap in here. The product description. Generally, I do research, educational, and DIY. That's the one I choose, and then I choose DIY, and that's all you need to. That's all you need to do. So with the shipping, you're gonna see a bunch of shit in my shopping cart. You can just ignore those. All right. So you would just, do the secure checkout. It'll give you the options for shipping. DHL is the fastest, but sometimes UPS or FedEx is a little cheaper, and that's how you would get your boards made. So they would make the boards and then assemble it, and within a week or two, generally possibly 2 weeks, you should have these at your house all done and assembled without you having to do anything. So save this website that I put here, the JLC PCB parts, because if they don't have the parts in stock, then they can't assemble your boards, All right. Now I'm going to show you guys some stuff that's probably, it doesn't apply to this board, but it can apply to the higher end boards that have high speed signals and shit like that. I'm pretty sure I included, let me just double check. Okay, the ULP, yep, you have the silk generator, the JLC PCB, and this other one here, the length frequency. We are going to use that. But first, I need to give myself a little bit of space, and you'll see why. So this right here is almost generally all the same length, very little, but the traces before it are not. See, this one's a little longer than that one. So I'm gonna push all of this kind of towards the outside, so I have space to for the traces. And I'll show you what I mean. Okay. So if you have a bunch, you want to know if these traces are, these look about the same, like I said, in lengthwise, but we can check that. We might want to rename these things instead of N money sign 13 or 14. It just makes it easier for us to see, but if we don't, it's not a big deal, as long as we know what they are. So we're going to go to the ULP menu. It's the very first one at the top. Okay. So this is going to give you a shit ton of information. So this tells you the frequencies based on the length and thickness and width and all that crap of each trace. What we're worried about mainly is this first one here. This is how long each trace is. So the N13 is 5.9 millimeters long, and the biggest one is this N16. So N16 is 8.771 millimeters long. So we're going to use that. We want to make the other ones match that length. Okay, so 8.771. We're going to have to remember that. So this little wavy thing here is called meander. You click on that, and then you write 8.771. Press enter. Now, any trace that we click on, it'll tell us the percentage we're off from that. So when you click on it, if you move the mouse up, you'll see it starts to, do a bunch of waviness to the trace, which adds length in total to it. This is why I wanted to have some space, because we're gonna need to fit all of this in there. So since we need a little bit more space, we could technically like move this into like a square, and then we'll have plenty of space there. And this one will have to do something as well. So let's try that. Let's not forget to increase the width of the trace. Okay, let's see. Do the meander. Got to add the number again. 8.771. Looks like we are actually over. This trace is bigger than the one on the bottom. Okay, let's try that again. Still big. Still big. Wow. Well, you don't need to do too much to this one. I'm just going to copy that, make it easy for me. Okay, so this one, right there gives us 100. This one here, we're off by quite a bit. You're going to have to like move it around to see if you can make small little waves, or you might have to make big ones. Okay, I know that's overlapping that, but we're going to do the same thing to this next one. So we might be able to just fix that. Alright, this one's probably going to be a little bit more of an issue. You can always go down to the bottom layer as well and run a trace there and then come back up. Yeah, it can get complicated. So very likely the best method would be to move all this as far over as possible. Make like a little hat for each one. This way you have space to meander the traces, and then this way they all have the same length. It's not going to be used by that many people, so I'm not going to go into crazy detail doing it, but that is how you do it. You know, if you need to do it, you can mess around with it and you'll be able to figure it out. But for most people that are watching this, I doubt you're going to be needing that option or using it. So other than that, I don't know what else I can show you guys. This has already been almost a 4-hour long video stream. I can show you how to make footprints and like your own library. Maybe we'll save that for another day. We'll see how much feedback I get from this video, and if there's demand for it, then I'll make one for that. Well, thanks for watching. I hope you guys learned something and you can start making your own PCBs, whether they're simple ones, complex ones, you know, and whatever you do, you know, show it to me. I'm interested in seeing what people do. All right, thanks for watching.